4.7 is use isosceles and equilateral triangles. Now, when we have an isosceles triangle, just so that you understand what we're talking about, we need to have it labeled. An isosceles triangle, remember, is one that has two equal sides and two equal angles. So, the two equal sides, or the two congruent sides, are called the legs. The bottom, which is the different measurements, called the base. And the two equal angles are called the base angles. So this is a base angle. This is a base angle. The one leftover angle at the top is called the vertex angle. So just so you understand what the language is that I'm using, that's what it corresponds to, is that picture.
At the top of that vertex angle?
Yeah, it's a vertex angle right here. The top. This is here.
Is that angle the base?
The base is the line at the bottom.
Oh, I see. How would you know what's the line at the bottom?
The line at the bottom is called the base. The two angles at the bottom are called the base angles. The base angles are across from the leg. So one is across from the leg, the other one is across from the other leg. Alright, now, we talked about this theorem earlier because someone used it in their homework last night, which was fine. It's called the base angles theorem. And it says if two sides of a triangle are congruent, then the angles opposite of them are congruent. So, if we have a triangle ABC, so if AB is congruent to AC, then the angles opposite them are congruent, so we can say angle C is congruent to angle B. And then this one also has a converse, so this is the base angles theorem, and now we're going to have the converse of the base angles theorem. And the converse is going to be exactly the opposite. If we have the two angles, the two base angles equal, then the sides, or the two base angles congruent, then the sides are going to be congruent. So in this case, now we're starting with the angles, and we'll end up with the sides. So, if angle B is congruent to angle C, then AB is congruent to AC.